Welcome to the final video on multiplication for this series on special topics in elementary mathematics. In past videos, we've looked at different ways of understanding multiplication, from geometric models such as area and scaling, to a wider range of models involving a variety of units. Hopefully you've also had the chance to think about some of the properties of multiplication. I'd like for you to reflect back on how your ideas about multiplication have shifted. Take a look at the answer you gave to the first question asked in the very first video. What is multiplication? What did you say then? How would you answer the question now? Would you expand on that definition, modify it, or possibly replace it altogether? Take a few minutes to reflect and post your thoughts in the online discussion forum. To conclude the series, I'd like to take a few minutes to discuss how mathematicians define multiplication. First of all, it's a binary operation, meaning that it takes in two numbers as inputs and returns a single number as its output. In this, it's like addition, subtraction, division, and exponentiation. What makes it different from these other arithmetic operations is the properties that it has. The first major property of multiplication is that it is commutative. It doesn't matter what order the factors appear in. A times B equals B times A. Multiplication shares this property with addition, although, as you may have realized, it's not necessarily as easy to see why multiplication should be commutative as it is in the case of addition. Nevertheless, our experience shows us that it is so, and so it's included among the properties of multiplication. The second major property of multiplication is that it is associative. When more than two factors are present, it doesn't matter how they're grouped. If we take the product A times B and then multiply by C, the result is the same as when we multiply A by the product of B and C. We see this property, for example, when we look at volumes of boxes. The volume is the same whether we multiply length times width first, then multiply by the height, or multiply width times height first, and then multiply by the length. The third major property is not just about multiplication itself, but about how it interacts with addition. Multiplication distributes over addition. Think of distributing as spreading out. What this means is that a number can be multiplied by a sum, or by each term of the sum after which the results are added, and the result will be the same. In symbols, A times B plus C equals A times B plus A times C. The final property of multiplication might seem a bit silly, but it's important. 1 times any number A equals A. 1 is called the identity element for multiplication because it preserves the identity of numbers. Together, these four properties define multiplication. They capture everything about multiplication that is important, regardless of the model we use to visualize or interpret it. When we first encounter multiplication, it just looks like adding a number to itself over and over. But as we've seen in previous videos, this interpretation only works when both numbers involved are whole numbers. To interpret multiplication in terms of areas or lengths or any other situation that allows for more general kinds of numbers to be involved, we need a broader framework. And this is what the four properties provide. So if you ever want a fancy name for multiplication, you can call it a commutative, associative, binary operation that distributes over addition and has an identity element. In all seriousness, these properties are the foundation for using and understanding multiplication. Even the usual algorithm we use for finding products only works because of the way multiplication distributes over addition, and the commutative property that addition and multiplication share. It's easy to get caught up in the algorithm to compute, say, 17 times 23. You multiply 3 times 7, write down 1, carry the 2, multiply 3 times 1, add the carried 2, now you have 51. Next, multiply 2 times 7, write down 4, carry the 1, multiply 2 times 1, add the carried 1. Now you have 34, but it's shifted over by one place. Add 51 to 340, and the result is 391. But what do all those steps mean? If we think about these four underlying properties, multiplication is no longer a magical process that we follow just because that's how it's done. We can know how it works, and we can think about how to multiply in a variety of situations. We can also more easily correct mistakes, because we're not just checking for errors in the process. We're also looking for conceptual mistakes that may have occurred in order to correct them. Multiplication is far more than times tables and an algorithm. It's a big step forward in the development of our mathematical tools, and understanding that can bring a new appreciation for it. I hope that these videos have helped you think about multiplication in new ways. Please leave any further thoughts or comments you have in the online discussion forum. I also hope this series has gotten you thinking deeply about other parts of mathematics. Mathematics is an important, useful, and beautiful human endeavor.